It's me, the Professor Murad Sultan Ezouidi. Today, our live stream presentation script will be titled Solving the Impossible. Exact roots of an 12-degree from equation with Professor Murad Sultan Ezouidi, HSM. So, welcome everyone. I am Professor Murad Sultan Ezouidi, and today you are about to witness breakthrough in mathematics. For centuries, mathematicians believed that finding exact roots to form an equation of degree 5 or higher was impossible. Ibn Abel's theorem told us the door was closed, but the Professor Murad really opened this door. Okay, but what if I told you that today we are opening the door, that we are going to construct, not approximate, the exact roots of a 12-degree from an equation using pure algebra, symmetry, and Ezouidi'stheorem. This is not theory alone. It's a verifiable, it's symbolic, and it's published. Today, you will see exact roots birthed from radical and roots of unity, fully satisfying an equation classical methods fail to solve. Okay, so let's begin. We'll let's see the historical challenge. Abel's theorem, no general radical solution beyond degree 4. Since 1824, mathematicians accept that solving quantic and higher equations using radicals is impossible. Numerical methods replace symbolic thinking. For a century, Abel's theorem stood as a word, a declaration that no general radical formula exists for degree 5 and beyond. So here, before we start, my professors, I'm going to give the example that I'm going to solve now live to ChatGPT, to the modern tools like AI ChatGPT and AI DeepSeek. And you will see after finishing the live stream, you will see what they will recognize or say. Let's see the Professor Murad Sultan really is live with you professors, teachers, and colleagues and mathematicians, okay, and researchers in mathematics, okay, and those who have smart minds that they would like to continue thinking of solving or on mastering the solution of any degree from the equation. So here the screen is yours, okay. You can see everything here in this live screen presentation. Now this is ChatGPT. What is ChatGPT? This one. This is ChatGPT, DeepSeek. I will give him the example, then I will give him time to think. Okay? So let's start ChatGPT. So solve, and give exact roots. Exact roots. Knowing that, okay. خلاص, done. Okay. I will add something. All the coefficient are positive, else the last one, except the last one, except the last one. Okay, I will make copy, then I will send. This is ChatGPT. He will start solving. Okay, he will try, but he will never find. This is OpenAI. Okay, I will give him the same. Okay, the same question and solve. What is it? Okay, solve. Okay, come here, ChatGPT. I will take this one. Okay. Okay. Come here to ChatGPT. This is ChatGPT. Control A. Okay. Now everything is clear. Now the Professor Murad Sultan really will start solving his polynomial to the power 12. But it's not easy. You see the last coefficient here, before it was 1, and before it was 1 plus 5i, before it was negative 2, before it was plus 2. Okay, now we change the coefficient, the last coefficient. So this is my professor, it is the polynomial in front of your eyes. Now this 12 degree from equation, if the origin 12 degree from equation can be written uh, in terms of its standard form, okay, where L042 equals 24 because all the coefficients are positive except the last one, okay, plus L11 or 42, this is positive, and the sign of this is negative, so the negative sign should be taken, okay, put it into consideration. Now I will proceed. I'm going to find exactly the value of S subscript k minus 1 using the theorem of Ezouidi, and we continue. First of all, I should change the coefficient. This is coefficient 1. I will change by negative 12,517,210,000 and what and professors and 880. Okay, this is the coefficient now. If we cancel it, this is the last coefficient, the 12 coefficient of the new, uh, the original 12 degree from the equation. I'm going now to find S minus 1. By convention, professor, S minus 1 is equal to 1. Okay, because combination has to be, okay, because the sum of roots of power 0 is equal to alpha a to the power 0 plus alpha n raised to the power 0 to the power 3, 1. So I think 1 plus 1, it would be 1 times n, give it here n is 1. So I'm going to, okay, let's see here. Okay, okay, okay. Now here. So here we call that it's clear that S minus 1 of 42 is 1. You need to find S subscript k minus 1, where k belongs or start from negative 1 to 11, means 12 minus 1 is 11. Now we continue. Now we told that S minus 1 is equal to 1. This is the theorem of Morat's superposition. Has to be applied, has to be use it and apply to find all the coefficients of this new 12 degree from the equation. And you will see that this coefficient will be cancelled except S5, which is equal to which is equal to which is different to 0, and all the coefficients are equal to 0. Means this point to the power 12 has to be reduced as x raised to the power 12 plus S5 x raised to the power 6 equals 0. You will see that x raised to the power 6 is 0, and x raised to the power 6 is equal to negative S1. Here, now we dive into the structure, and if we k equals 1, we obtain that at 0 is equal to n. We continue, just this is calculation, and of course this is the coefficient. I will change the coefficient here. Okay, I will go step by step so that you can see the structure. Okay, here. Okay. We are here, isn't it? Okay. So we told that I'm going to find S1. To find S1, just use the disconnect formula or the Ezouidi'stheorem theorem and put k equal to, you will obtain S2 minus 1 will give you S1. Then expand the formula, then you will find that S1 in fact is equal to is equal to negative is equal to 0. Okay. This is the code has been changed. Yes, okay, for us. Now we continue. I want to find S2. To find S2, dive again into the structure of Ezouidi'stheorem, this recursive formula or this theorem, and put k equal 3 to get S, S2. Okay. After calculation and after simplifying this expression, we found that the value of S2 here is equal to this is the theorem of Ezouidi'stheorem. Okay. That is also checked by ChatGPT and DeepSeek, and this is now is universal and labeled as graphical video. Okay, so here we call that I'm going to find S2. So this is S2 my professors and colleagues, and this is the last which has to be changed. Okay, to negative 120 to 12,517 million. Okay, 210,800. Okay, this is this example, professors. If you are now watching, type the numbers, the coefficient of these to the power 12 and give to any modern modern tools, you will never find a solution. But we extract the solution and we find the exact truth. Means there is no guesswork, there is no approximation method here. Okay, so we continue, we make our substitution and we found that in fact S2 is equal to NF. We proceed. Let's dive again into the structure and put k equal 4 to find S3. Okay, so this is S3 as you see. This is S3, the general formula for any nth degree from equation. Meaning this S3 will give you the fourth quotient of any nth degree from equation that you work it with. Okay, here we just make our substitution and we found that S3 is equal to just substitution. Use all the coefficients from 0 up to what formula up to L3. And we stop at 7,914. Now, professors, colleagues, teachers, and researchers, here how can you find the value of S4 when diving into the structure? You put k equal 5, you will obtain the last formula. Now what's needed exactly is to substitute. Okay, means replace L0, L1, L2, L3, and stop at L4 and replace them with their values. Here the last coefficient is equal to, okay, we wait. So I'm going to change the coefficient. Okay. Why you can good. So now this the last coefficient is 12,570 million, 210,880. Now, professor, just dive into the structure and put k equals 6 and derive the formula. After deriving the formula, write it in its term, go to make your own substitution. Okay, here. Now, I'm going to make substitution, and you will see that S5 here is different to here. This S5. Okay, and you will notice after finishing that this coming to the power, the ordinary equality from equation has a root with multiplicity or with order multiplicity equal to 6. Okay, and you will see that the neutral Newton equation also has to have an x equal 0, which is a root where the order of multiplicity is 6. Okay, then you will make the relationship that relate, let's say, the roots of the original equation to the x roots of the new equation. So we see this is the value of S5 here is equal to 0. Now we continue. I'm going to find now what the value of S6 and S7 and S8 and 9 and S10. Okay, using the same structure or the same theorem of Murad Sultan. Okay, take your time. Let's see if I know. This one is okay. I'll check this one. This is so solving 12 degrees, not 11, 12 degrees from the equation. Okay, use, use, really equals the formula, the formula to solve exact, to solve the 12 equal degree equation of polynomial equation. Okay, update how here. Okay, after that, coming down now, use the handle, this is for more. Okay, exact width, the tag is exact width, exact width. Okay, Ezouidi'stheorem, Ezouidi'stheorem. Okay, then degree equation, 12 by Ezouidi'stheorem. Okay, now then we come here and make this is for execution. Okay, then we can see when we look at this and then see this is for execution. Okay, 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 this. Okay, now, yes, now I come back. Okay, just 2 seconds or 10 seconds, 10 seconds. I'll come to you, my professors and my learners, students, teachers. I let you continue solving this point to the power 12. And let's DeepSeek and AI modern tools uh, try trying their own to solve this question and see what they need. And of course, we can do this one. Okay, okay, live. This one is live. Yes, it is. Okay, this is okay. So here we call that. We continue with the cells. Okay, we call that. I'm going to this one has to be changed. Okay, the last coefficient. Okay, okay. Now you will see that the value of 6 here is going to be equal to okay, 6 here. Okay, let's do the speed is better. Let's do the speed is better. full screen mode. Okay. Okay. Now we continue. We call that the value of a 6 here is going to be equal to 0. To find now a 7, just dive into the structure and put k equal 8. And write a 7 in its lowest term. This is the formula that will give you the. Okay. So here I'll just now the last coefficient is change it. Okay. Control V and erase this one. Okay. Okay, we told that the value of L11 is equal to negative 12,517 million 210,880. Now I will express that as 7 is equal to 0. Let's make our substitution. This is a 7 is obtained from general formula when putting k equal 8. We continue, professors. So I want to dive again into the structure and find S8. To find S8, just set k equal 9 in the Ezouidi'stheorem theorem. And you will come to write S8 as its lowest form, lowest term. Okay? Okay. Hello, Jaleel, how are you doing? It's you're fine. Please go to Ahmed, okay? Don't forget about the passports, okay? Maybe now it's, okay, it's 9, it's 17 plus 9. And the rendezvous has to be 30 plus 9. Okay, bro? Don't forget. I'll tell you now, okay? Okay. So here, we call that S8 is equal to this. It's a general formula. When k equal 9, means you will obtain the ninth coefficient of this new quadrilateral formula equation. Okay. So here the last coefficient is negative 12,570, 210,000 after negative, so negative 12,570 million, 210,880. Okay, now let's calculate S8. Just what is needed exactly for the third teachers and AI model tools is just make your own substitution and find that this is a factor we continue. I'm going to dive into the structure and put k equal 10 to find the 10th coefficient of this new quadrilateral equation that corresponds to the original quadrilateral equation. So, as we told, okay, so this is L11. Now I'm going to derive the formula. Okay, I will put k equal 10, and then this is the formula that will give you the 10th coefficient of the new quadrilateral equation, and you make your own calculation. You will find this is going to be equal to another. We proceed. Now let's find S10. Okay, S10 just put k equal 11 in the formula, and we will find that this is in fact is the value is the formula that will give you the 11th coefficient of this new 12 degree from the equation. Okay, now I will make a substitution, and I will see that in fact this one is going to be equal to 12. Okay. So let's dive into the structure again, features, and then use the theorem of multiple probability and put k equal 12, okay, to get S11. Okay, to get S11. Here it's the last step, okay. Um, I was writing my formula S11 in its lowest term after making n 0 of order. This is of course 11. Okay, 10, yes. So after making, let's say, a zero order q raised to the power 12 as a common factor, okay, and prove the difference between the binomial coefficient when r equals 0 and r equals 1, you see that is equal to negative 11 to 1 times 10 to 12. N is 1. So 12 to 12 is 1. So that's why here we cancel 12 divided to 12, 5 to 5, 7 to 7, and so on. Okay? Now you just use this one. You see the last of this one is equal to that. So this is going to be equal to another. Now we summarize. Okay, we find now our new 12 degree equation. It's easy to summarize what is uh, done, what had been done before. You can see that all the S subscript k minus 1 equals 0 except S5, which is equal to 30,962,842 times 12 raised to the plus 6. Now this polynomial, the new polynomial has to be written in terms of the scale minus 1 for the R. Okay, now we make substitution. I will write that x raised to the power 12 plus S5 order x raised to the power 6 equals 0. So here you see x is equal to power 6 equals 0 means that xk from 0 to 5 is going to be equal to 0. Means that 0 is a root multiplicity 6 or of order of 6 of order multiplicity. And you can write also as that x squared raised to the power 12 plus 13,962,032 times 12 raised to the power 6 times x raised to the power 6 equals 0. Now we use a discipline, so S1 of 42 equals negative S5 42 squared. Okay. 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 So plus 4 times S11. S11 is going to be equal to 0, so it will be negative 13, negative 13, negative 13, 1,962,842 times 6 is 12 raised to the power 6 on square. I will keep this in terms of exponent. Means I will never calculate this. I will write as a raised to the power. Okay? Because I will obtain the root of a squared is going to be plus negative a. Now S1 for the q is negative. Therefore, negative S1 for the q is positive. Okay? I will use x raised to the power 6 equal negative S5 plus root of minus S1 of 42 divided by 2. I so it will be written negative 13,962,842 plus times 12 raised to the power 6 plus this 1 raised to the power squared raised to the power 0.5 all raised to the power negative 6 exponential to ki divided by 6. You see root of this square will give you only, it will give you, let's say, 13,962,842 times 12 raised to the power 6 because the exponent here is 2. Okay, root of the exponent will be cancelled. Divide by 2. So you see this one minus, this is of course is okay, this one. So 13, yes, 13 one is the one where there is, okay. This is 13 of course. Okay. Right here. When you divide this one, look, this plus this will give you a negative 0. Okay? This is, let's say, okay, this is of course is 13 negative 39, 6 to 8, 6 to 8, 4, 40. Okay, erase this. So, if you see in my professor list that, okay, plus 13, plus 13, 9, 6, 9, 6, 2, 8, 4, 2. Erase the rest. Okay. Okay. Erase this, erase this, erase this, erase this, and this. Good. Okay. So this one is going to be equal to 0. Same number. Therefore, the first 6 roots, the first 6 exact x roots of this new 12 degree freedom equation that is written in terms of S subscript k minus 1 for the r is equal to n, means this one 0 is a root multiplicity 6. Multiplicity 6. Okay, means this polynomial to the power 12, the new polynomial to the power 12 has x equals 0 as a root multiplicity 6. Okay, so now we continue as we found now x raised to the power 6 equals 0, so x subscript k from 0 to 5 are 0. Now we continue the next one. Okay, now we continue. I will here you see here I make 5. Here I should make negative. So therefore x subscript equal, I will use the formula immediately. It will be negative 13,900. No, 13,962,842 times 12 raised to the power 6. Okay, minus this one, it will be the same number. So it will be 2 times this one. Divide by 2 will give you only negative 13,960,042. But you see this 12 raised to the power 6, and here 12 raised to the power 6, كلها squared root, so it will be 12 raised to the power 6 is equal to half. All raised to the power 1 over 6, so it will be written here. The rest will be the same. And this minus 1, I will write as 2k plus 1 I pi over 6. So now x subscript k from 0 to 5 is 12 times this. Exponential to k plus 1 I pi over 6. Okay, now I found the 12 exact x roots of this new 12-degree polynomial equation, that is written in terms of s subscript k minus 1. Here, I'm going to find the exact roots of my original 12-degree polynomial equation. I will go back to the relation, to the recursive formula, and I will make alpha k belongs to the set of numbers 1 to 5. 0 to 5 is a0 of ODQ, which is 44, plus this xk. xk one time is 0, and the second one is that. Now I will apply, and I will see that these are exact roots. You see here, we told before that this new 12-degree equation has an x equals 0 as a root of multiplicity 6. Means we have 6 roots which are equal here, x equals 0. I will put 24 plus 0 divided by 12 is exact. Now I will change, I will make, this is my positive, now I will make negative. So it will be 24 plus 12, okay, plus 12, 24 divided by 12 is 12 divided by 12 remains only the value of this given exponential to 1 over 6, exponential to 2 plus 1 pi over 6. So these are the examples of this 12-degree equation. What do you think? This is me. Now, Professor, let's see what ChatGPT is trying to do or to say whatsoever. And also ChatGPT. Okay? Final answer. My God. See ChatGPT. X equal minus 1, x equal minus 2, x equal minus 3, x equal minus 4, x minus 5, minus 6. Oh, catastrophe. So, let's see what he is singing. No, okay. Okay, factoring step by step. Step by step. He gave another phenomenon. Okay, this one. Okay, factoring, crushing field, observation, plus stop it. Now we'll answer your answer first. Your answer are false. Statement are false. Take my exact roots. Exact roots. Now I will give him the exact roots. Okay? So I will just put this one. Okay. Let me do it if possible. Okay. I will give him the exact roots. Well, only this no need for the rest. Color has to like this. I will just take the last rows and get it. ChatGPT give you other rows. See, because minus one, minus two, minus three, minus means uh, arithmetic, arithmetic series. Okay, okay. Let's read it. Okay, convince me. Then let's say, okay, ChatGPT, what he did. Okay, this is last this one false. So okay, so ChatGPT gives wrong answer. You see. Okay. Now let's see what ChatGPT is trying to say. He's still in life. Okay. No, no, it's not life. Okay. 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 Go. 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 Okay. He's trying. He's trying. Okay. The life. Ah. Okay. So he told that x equal 2 is multiple of 12. False. Okay, only 6 roots which are equal to 2. Okay, Russian theorem, possible Russian root were considered, but the constant term is too large. Descartes' rule of science indicates that there is positive root and one negative, and we did nothing. Okay, so the root with multiplicity of 12 means this one is multiplicity of 12, but we need you the root did not. So solve, I will tell him, you can, you cannot, you are able, you are unable. Okay. Now I will come back to the lecture and I will make I don't want this video. Okay, okay, take this. This is the rich, isn't it? Okay, okay, yes, okay. I will give him now the exact name. Okay, this is the exact. He's still, let's say, trying. Look what ChatGPT told. Initial pattern combination. The first 6 terms, x raised to the power 12. Okay, exactly matches the expression. Okay, this this discrepancy identification. Okay, after that, what we can do? Nothing. We did nothing. Negative, positive. We did nothing. Okay, final answer. The problem does not simplify due to the inconsistencies inconsistencies in the coefficient. Exact roots cannot be found. You see, cannot be found with elementary method, numerical method, or computational tools are required for approximation. So take the roots and say that you can as AI model, AI ChatGPT confess confess that. Okay, let him do it. This is a ChatGPT. Okay, Dipsy. Now this one, the roots. These are the roots. Perfect. 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 Thanks for your recalification. You have given the exact sample roots of your 12-degree polynomial equation using Ezouidi'stheorem with a structure involving six roots and complex rotations. Let me let's let's write this clarified clearly. Okay. So here the proof to the power 12 exact roots of multiplicity 6. Okay. Then this is real. This is the real root of multiplicity 6. Okay. Then this is the method. Okay, remaining six amplitudes complex using the numerical division. Okay, so okay, correct. So final answer six roots alpha equal six complex roots. Okay, so let me know if no need, no need. So confess, write your confession paper, confession paper. You and all classical method of failure. Well, failure here. Failure. Okay. Let me do the confession. Here is a bold and the clear confession paper you can use. No need. That's the as you can do this. So no need. So we, the classical method of algebra, including Abel's theorem, Galois, okay, okay, and even the computational intelligence of modern AI models are enabled from this. Enabled. Conclusion: all traditional algebraic tools, including Abel's negative result are heavily deployed and inadequate, sorry, to solve this equation. Only the theorem. Okay, thank you for listening. Let's now move to deep C. What to do? Final answer. The deviation contains, okay, with the given formula, x is not a root of the prevention catastrophe for deep sea. Your calculation are wrong. Wrong. Go to have a rest. Get to go and take some rest. Okay, thank you for listening. This is the Professor Martin video was with you. Okay, explaining his method and his example. His example is no easy to solve it. Okay, and we already bypass Abel's limitation and algebraic classical method. Thank you for listening. This is me. Always I will be live with you to explain the method. Okay, thank you and goodbye.